Questions do you think the finals gonna have roughly?
I don't know, probably 50 or so, something like that. Could be more than that.
Hey, she loves us.
Can't remember. Probably even more than that. Okay, now let's try to review a little bit. Okay. We have a lot of different things that we covered. We're just going to cover one more chapter, which is statistics, and it's not much on statistics. Okay, let's look at 9.2. We're going back, may even start at 9.1. Okay, this is the geometry section, and we talked about in 9.1. We did like point, line, and plane being the three undefined terms of geometry. As much as I've said that, you probably know that'll be a question. Okay, because they were so simple that everybody knew them, so Euclid didn't even give a definition for those. And then he wrote a book called The Elements, and we study Euclidean geometry. There are other types of geometry, but the type that we study is Euclidean. Okay, then you had to be able to talk about lines and angles and planes and things like that. We had right, acute, obtuse, and straight angles. Right equals 90. Acute is in between 0 and 90. Obtuse is more than 90 but less than 180, and straight is equal to 180. Then we had complementary and supplementary angles. If you're talking about complementary angles, how many degrees would they be if they were complementary?
180.
Complementary is
No, 360.
90. 90. Okay, if you had two angles and it said they were complementary, that means they're going to add up to 90. Okay, so your picture will not look like that. Can't see it. I cannot, this thing has quit adjusting to where I can get it bigger than this, because ordinarily you could just smash that button, but it's doing nothing. But anyway, so if it says two angles are complementary, that means they add up to 90 degrees. And if this one is x and this one is 50, then to find that, it would be 90 minus 50 would give you 40, or what plus 50 adds up to 90. Supplementary would be two angles that add up to 180 degrees. Then they had problems where you put in different numbers like x plus 1 and 5x and stuff like that. Then you also had things like, let me get a sheet of paper, where you had parallel lines and a transversal. And the parallel lines, they mark parallel lines by putting like a little arrow on it or something like that. You have a transversal. You can find out all of the angles if you know one of them. Okay, if that one is 110, then that one is 110 because they're what kind of angles? Remember the name of that?
Alternate?
Vertical. Vertical angles. Now this one and this one would be alternate interior. They're inside the lines, so that's interior. They're alternate. One's on one side of the transversal, one's on the other. So alternate interior.
And the vertical is where the vertex.
Yeah, they're right across from each other like that. And those, yeah. And that does have to do with the vertex. Okay. Now, what are those two types called? There are a lot of terms in geometry that you need to go back and go over, because I might ask you a question.
That's the thing. Like, none of this is like hard. It's just a lot to keep up with.
Yeah, a lot of memorizing in geometry. In algebra, you just do it, But in geometry, you have to know the terms. Okay, these correspond with each other. They're in the same position. They're both underneath, okay, so they're corresponding. What do you think this one and that one right there would be called?
Alternate exterior.
Alternate exterior. Good. Okay, because they're on the outside of the parallel lines. Now, if this is 110, that makes a straight line right there. So how much would this one be? 70. Okay, because straight line is 180. So 180 minus 110 is 70. So all the rest of them are 70. Okay, and I was glad to see on some of your papers that you drew these things out, because that's the best way to do it, is don't look at what's in the book. They put too much stuff in there. They put the number of all the angles, and that gets confusing with, the actual angle measurement. Okay, so we did that. If you had one like this, okay, and this is x, and this is 5x plus 6. Raise your hand if you know what the equation would look like in order to find x and then find the angles. Raise your hand if you think you know what the equation would look like. This is a 5x plus 6, and this is an x. Okay. These two add up to 180. So x plus 5x plus 6 equals 180. Okay, see that? All right, straight line. So this one plus this one adds up to 180. Then you have to combine like terms. 6x plus 6 equals 180. Then solve the equation. See why you have to have algebra before you have geometry? You have to know how to solve an equation. So that's 6x equals, is that 174? Okay, then you have to divide through by 6, and you get what x is equal to. Then once you know what x is equal to, then you can stick it back in here, and there. This one will come out with a decimal answer. But those are those types of problems. And if I were you and I get ready to study for this test, if you can read your notes, you can just go through your notes and see what you need to know. If you can't read your notes, then you need to look at the book. And I have trouble being able to
I'll
read
watch
mine.
all the lectures again.
Right, right. Yeah, you can do that if you have time, but most people end up not enough time. Okay, on 9-2, you ended up looking in the back to check your work. Always check your answers, otherwise you're wasting your time. You're just doing a bunch of junk for nothing. But if you work it, get the right answer, you know how to do it. If not, then you need help. Okay, on this one, it gave you, this was x, this was like 138, and this one was 25. So we knew that one was 25 because they're vertical. We knew that this was 138 because they're vertical. Then the three angles in any triangle always add up to 180, right? Okay, so you said 138 and 25, added them together, then took that away from 180, and so x would be 17 over there. That was number 29. Okay. Alright, another problem that you may or may not have had trouble with is number 31. Okay, same type of problem. On 31, they gave you this was x. Okay, they gave you this one was 27 and that one was 57. Okay, so this is 27. They're the same, and then 180. I didn't do that right. Minus 57. Okay, it's 123 on this one right here. 123. Okay, mark all that out. Okay, so if you know two angles, they add up to 180. So you add 123 and 27 together. Is that 150? And so that one would be 30. Okay, because 180 minus 150 would be a 30 right in there. Okay, Then, if you know that this one is 30, then 180 minus 30 would be 150. Okay, so your final answer on that one was 150. Okay, another one, number 33. If you look in the book with me as we go through these, okay, what this one gave you was this. You have two parallel lines, and then you have a bunch of lines like that. But these two are parallel, okay? This is 63, and this is 67, okay? And then they want to find all the rest of the angles. Draw your picture separate like this where you can see it, okay? So you would add these two together, subtract from 180, and you get that one over there, right? And if I did this right, I think that was like a 50, okay? All right, then if this is 50, then this has to be 130 because they add up to 180 degrees. It's a straight line. This is 67, that's 67. This is 63, that's 63. If this is 50, then that one's 50 because they're alternate interior. Same thing over here. This one and this one would be the same. Okay, see how you have to do it? And then that's 130, that one's 50. Then over here, this is a straight line. So if that one is 63 and that one is 50, you'd add those two together, subtract it from 180, and you get that one right there. Then, same thing over here. That one's 50, that one's 50. So anyway, there's all sorts of different things. And then that's a straight line, so 180 minus 67 will give you that one. That one would be the same as that one because they're vertical. But anyway, draw it separately, put in what you know, and then go from there. Okay. All right, number 34. Okay, look at this one. Okay. Now, it looks horrible when you look at it in the book. You think, there's no way I can get all that stuff. But you can. Okay, but you have to start with what you know. It started with, this was 40. Okay. And let's see, this one was 50. And that may have been all that they gave you. Okay, I think it is.
It is.
No, yeah, it is. Okay. All right, so if this one is 50, this one is 50 because they're vertical angles. This one is 40, this one is 40 because they're vertical angles. Now you got to step back and look at it and think, these are parallel lines right here. This one is a transversal. If you have to, draw it separately like that where you can see it. Can you see if that one is 50, then that one would be 50? Okay, so that one and that one, are 50. Okay, then this one over here is 50. Okay, then you've got, you have this measure, that measure. So 50 and 40 is 90. So this one has to be 90 because they add up to 180. Then if that's 90 and that's 50, then add them together, subtract from 180, and you get 40. Then that one and that one are the same. Then there's a straight line. So 40 and 140 is 180. That one and that one are vertical, so they're the same. Okay, this one was 90, then that one is 90. So forth and so on. So, but anyway, always draw it, put all the numbers in.
Can't you take the triangle in the middle and get 180 since that one top?
Uh-huh.
The interior angle is 50. That means the adjacent one's 50, and the one up top will probably be what, 80?
These two are 50 right there.
We're looking at 34, right?
And okay. Because you didn't have this one, but I just wanted to give you one. But you find straight lines and triangles and vertical, alternate interior, whatever they are. You look at them, like that and that. If you can find two angles of any triangle, then you'll know what the third one is.
Yeah, if I did this problem, I don't know, I'm weird. I'd probably draw it sideways just because it's easier for me to get the parallels to be
Right,
kind
yeah,
of-
exactly. Okay, so and if you need to, just turn it. You can also take it out like that and look at it, because sometimes it is so much stuff in there that you can't see it. It's
I did
just
all
too
my-
much.
I did all my scratch work on graph paper. It makes the lines easier.
Uh-huh.
It makes it easier to see.
Right. Because I like to do it on, you know, something that has lines. Okay. All right, look at 41. Okay, it says to determine the exterior angle of this triangle. If you extend any side of a polygon, it makes an exterior angle to where it's like a straight line. So if these are regular polygons, remember the word regular means all the sides are equal and all of the angles are equal. Okay. If it's a regular octagon, these are all the same and every one of the angles, the interior angles, are the same. So on 41, if it's regular, then there's 3 that are the same, so 3 are going 180 60 times. So this is a 60. That makes a straight line, so it's 180. Okay. 43, this one is 1, 2, 3, 4, 5, 6, 7, 8. Okay, is an octagon. Okay, you remember this formula? N minus 2 times 180? To get the interior angles sum, you take the number of sides minus 2 times 180. So 8 minus 2 is 6 times 180, or 1,080 if you added all of these interior angles up. We have 8 of them since it's an octagon, so I divided by 8 and got 135 for the measure of one of them. So that's 135, that's 135, that's 135, that's 135, so on, so forth, so on. Now, extend one of the sides to get an exterior angle. They want that one right there. So 135 plus 45 equals 180. So that's how you had to do those. If you had something that was alright, if it was a 6-sided figure and they said it was regular, then all the sides are the same and all these angles are the same. You would use that same formula, n minus 2 times 180, to find out the sum of all of them. Any triangle, what is the sum of those 3 angles? 180. Okay. Remember how you can also, if you can't remember the formula, you can divide it up into triangles. 4 times 180. Same thing as that, you know, because 6 minus 2 is 4 times 180. Okay, so you never know what kind of problem you're going to have on that. All right, on number 47, these are just, I'm just picking out some that you may or may not have had trouble with. And if you, let me get another piece of paper. And then I'll work any of them that you did have a problem with. Okay, these two were similar figures. Okay, you got to go back to your definitions again. What does similar mean? The angles are equal and the sides are in proportion. Okay, which means they're the same shape but different sizes. One's, you know, bigger than the other. Okay, you always have to find out which ones go together. Okay, so on 47, all right, they put red on there to show that that's what you're trying to find is X and Y. But you've got A, B, C. Here's A, B, C. And here's A prime, B prime, C prime. To tell you that the A's go together, the B's go together, and the C's go together. Okay, now, anytime you've got similar figures, you're going to set up a proportion. And you find the 2 sides that both have numbers. Which 2 sides on this one have numbers? The ones that correspond. The sides that correspond with each other.
The top slant.
Right, 10 and 4. So that's what you're going to use. So you say 10 is to 4, as if you're trying to find X, X is to 2.4. If you're going to find Y, you still use the 10 and the 4 and the 8 and the Y. Cross multiply, so that would give you a 24 equals 4X. Then solve it, so X is 6. Over here, cross multiply, 10y equals 32, and then divide, so it'll be 3.2. So, all similar figures, that's the way you're going to work it. You're going to set up a proportion. Now, here's this one. This is 49. Okay, you can tell they're the same shape but different sizes. What are the two numbers you're going to use? The two sides that both have numbers on them. 4 and the 10. So it'll be 4 is to 10 as x is to 6. 4 is to 10 as what is to y? 3 is to y. Okay, so that's how you would set them up, and then you would cross multiply. Okay.
I have a question with 47, 49. I got the same answers that you got, but in the back of the book it had fractions, and fractions. I don't understand.
Okay.
But
use decimals. Use a calculator.
Yeah,
Use a decimal.
And I tried to, like, whenever I saw the fraction in the back of the book, I like divided the fraction and it came out as a decimal.
Yeah, and it's the same thing. So you're fine, because I can figure it out. But if you've got a fraction and I have a decimal, you know, just like you did. Okay, because these will definitely have decimals, and so will that one. And it doesn't matter if it's a fraction or a decimal, as long as they equal each other. All right, here's 151. Okay. All right, now, you can tell which ones go together because it's A, B, C, A prime, B prime, C prime. Okay, which two sides have numbers? What are they?
The bottom side's 2 and 1.25.
Good. The 2 is to 1.25. And if you're trying to find x, it's x is to 0.75. On this one, 2 is to 1.25 as 1 is to y. Okay. Anyone need to see that one worked out since it does have decimals in it? Because sometimes that is the problem, you know. Anybody need to see that one? Or did you get it?
Yeah, I'm like just getting better with decimals and fractions.
Okay. That's right. Yeah, because you can use your calculator. And nobody does fractions by hand anymore.
I'll pull one over on you.
All right, on 53, these are the hardest kind. Okay, the similar figures are the big one and the little one. So you have to take them apart, then you have to put them back in to see what you're looking for. Okay, on 53, you're trying to find side BC, or this one right here. This is B and this is C. So that's what you're trying to find. I'm going to call that a Y, I guess. I do better with X's and Y's than I do with BC, AD, you know, all that gets confusing. Okay, so I just call it a Y. And then I call that side an X. So you've got this one, and this one is inside of the big one. So I put them like that. The whole side is a Y. This little part, it gave you that was a 2. So that's a 2. It also told you that was 2. Alright, and it told you that this whole thing was 10, but we don't know how much that one is, so I put an X over there. Now I can set it up by finding the two sides that both have numbers, and those are the two sides. 6 is to 2, if I want to find this side as 10 is to X. And then 6 is to 2, if I want to find this side as Y is to 2. And then cross multiply. So that 6x equals 20, and then divide. And this is 12 equals 2y, or 6 on that one. So if you've got anything like that, just take it out and look at it and then put it back in. But that's the hardest one in the book, on this chapter. Now, the next thing we had were congruent. And so congruent means equal angles and equal sides. They're exactly the same size and shape. Okay, everything's the same. Okay, you match them up according to their ABCs. Okay, now I don't even know which one this is. I may have just made it up. No. Okay, it's 57, I believe. Yeah. Okay, this is the ones 57 through 62. Okay, what I did, since they were congruent, I put them side by side and matched up the angles. I matched A with A prime, B with B prime, and C with C prime. And I labeled everything that they gave me. Okay. So, if this angle here was 84, then I know that A prime is going to be 84. If B is 68, I know B prime is going to be 68. If this one's 28, then that one's 28. Then the side AB, it gave you was 14. So A prime, B prime is 14. Then it said that A prime, C prime over here was 28. So that means that AC is 28. So if they're congruent, you just draw them side by side, facing the same direction, and put everything over there. Okay, those are easier than the similar. Okay, another one, 73. Okay, it's one of those where you've got a figure inside of a figure. Okay, see, here's this little triangle. It's similar to this big triangle. They have the same size angles, but their sides are in proportion. That's what similar means. Angles are equal, sides are in proportion. Okay, so if I took this little triangle out and put it down here, and I put it in the same direction that I did that one, and it said the whole thing down here was 105, so I wrote that down. It said his shadow is 9, so I put it here. It said he was 6 feet tall, so I put it here. Now I've got two similar triangles. Can you tell by looking at that? And that's kind of small. What two numbers go together?
9 or 105 and 9.
Right, 105 and 9. So I would do 105 is to 9 as whatever I was trying to find out. Okay, if I wanted to find x, then that would be x is to 6. And then cross multiply and get your answer. Okay. 79, these are similar triangles. Did you recognize that as similar triangles when you looked at it? Okay, so these angles go together, those go together, and these go together. And then these two sides and those two sides. So you find the ones that both have numbers. 2.5 is to 20. Now if you're doing that in your calculator, 2.5 is to 20. Okay, as 5.5 is to x. Okay, so there's your equation, and then you cross multiply and get the answer. Now, if you've got one like this, and you set it up right, but you make a mess, you know, with the other, you still get partial credit, you know, setting it up right. Now, any other ones that you have a problem with that I did not go over on 9-2? Okay. All right, we'll go on to 9-3. Now, some people, this is easy. Other people, this was horrible. Okay, so it just depends. Now, when we have our final test, you will be able to use your book and your notes. Okay?
What
Because
about on? Can we use on?
no, cannot use someone else. Book and notes. Okay. Now, which is good because it's so many formulas and all of that, and nobody memorizes all that anymore. You look it up on your phone, you know. Okay, so I live in the real world too. Okay. Okay, now 9-3, you've got perimeter and area. Perimeter means the distance around. Area means what's inside. In this room, the perimeter is this, 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 and this. And it is in linear units because it's like a line. You know, you're going to get so many feet. All right, if you want the area of the bottom, you get square feet because you got squares down here, and that's exactly what that is square feet. So if I was in middle school, we would go measure that and that and that and get the perimeter, and then we would do the area. All right, now, and what's funny, my grandson's, he's 15. He's been studying the exact same stuff y'all have been doing, and he has to do, you know, the area and perimeter and volume, and then he did like the power of a power and all that. But he had even harder problems like x to the third to the 3/4 power and stuff like that.
No.
And that looks horrible, but it's not. Because when you've got a power of a power, you multiply. So that's a 3 times 3/4 or 9/4. So it's x to the 9/4. It's funny how things look horrible, but they're really not if you remember your rules. Power of power. Okay, anyway. All right, first one I wanted to go over was number 13. Okay, number 13 on this is using, you're finding the area and perimeter of these different things. Okay, the quadrilateral. Quad means 4. Alright, this particular shape happens to be a trapezoid. Now, a lot of times that's the problem. It's like, I don't remember what shape that is, you know. So you look back on 498, and you're welcome to put little markers at different pages that you know you're going to need, you know, that sort of thing. Okay, now, so the formula is 1/2 the height times base 1 plus base 2. So you fill the numbers in. The height on that is 2. Base 1 is 5, base 2 is 19. It doesn't matter which one is 1 and which one is 2. Okay, it still works. Use your order of operations. So you do what's in here first, so it's 24. And then half of 2 is a 1. 1 times 24 is 24. And this one, if you're doing area, it's square inches or inches squared. If you're doing the perimeter, you just add 25, 25, 5, and 19 together. Okay, piece of cake. All right, once you get used to working the formulas, then it's not that hard. All right, now, when you got over to 23, these got complicated. He was doing these this week too. Okay, now, you want the shaded part in here. So always when you have this kind, like we have in our notes, I said get a plan. Okay. And if you remember 18, the plan comes together. Okay. All right, now, so you want the area of the big circle and take out the little one, and that'll give you what's left, you know, the shaded part. So formula for the area of a circle is pi r squared minus pi r squared. Now, this first one, the radius is 4. So pi times 4 squared, or 16 pi. Over here, the radius of the little one was 3, so pi times 3 squared, or 9 pi. So 16 pi minus 9 pi is 7 pi. Now, if you leave it like that, that's okay with me. Okay, I don't know how the answers in the book were. I didn't look them up. But anyway, you can do 7 times your pi button, and you get your answer. If it says round this to the nearest blah, blah, blah. Now, this one says round your answer to hundreds, so that tells you what you've got to do. So you do that and on your calculator. All right.
We'd like to go back to number 7.
7? Mm-hmm. Mm-hmm. Okay. All right, number 7. Okay. This one, the area of a triangle. Okay. Okay, area equals, what is it, 1/2 the base times height? Is that what it is? Okay, the base on this one is a 7. The height on this one is a 5. The height is always a perpendicular segment to the base. So that looks weird, doesn't it?
Yeah, it look weird.
Uh-huh, right. But, so it's just 7 times 5 is 35, half of 35.
Oh.
Okay,
Hmm.
okay.
17 and a half.
What?
It'd be 17 and a half.
Yeah, mm-hmm. Okay, other ones? Okay. Anything? 8? Is that what you said?
No, just a question. Like 6 months ago, I did a patio for this old lady in her backyard,
Uh-huh,
and I could not figure.
4-inch bricks is what she wanted laid down,
uh-huh.
and she had 17 feet wide by 32 feet long. How was I supposed to figure out the exact volume of the 4 inches with a formula without having to go to Lowe's and be like, could you help me?
Uh-huh, okay. Feet wide, 32 feet long. And then she wanted brick,
4-inch tall brick.
4-inch brick. Okay, just to line this particular thing. Okay. Alright, okay. So in this particular one, would we be using area or perimeter?
The perimeter.
That's
Perimeter.
referred to.
Okay, so if this was 7, let's say this is 32, and this is 32, and this is 17, and this is 17. Okay, so, and they're 4 inches, so how many would be on this side?
17. I mean, yeah, 32.
Okay.
32 and
Okay, if they're 4 inches long, how many of them are gonna go in there?
8. Yeah, 8.
8. Okay, so you'd have 8 there, you have 8 down here. And then this way, you'd have, if you're doing 1, 2, like that. Okay, so 4 into 17, right? Okay, 4 and 4. So you'll probably have to chop off some of them. But anyway, so you would lay them like that and do like 8 that way. And then you would, but the problem is on here on the ends, you know. So you just get a rough estimate. That's where we estimated, you know. So it's roughly going to take 8 and 8 is 16, and then 4 and 4 is 8 and a little bit more, so 9. So about 25 of them is what it would take. Okay.
With
and
the
then,
brick,
mm-hmm,
because like you're
mm-hmm,
doing all the way across,
uh-huh,
so even if you get your measurement for your side, it's not
mm-hmm.
going to be exactly what the measurement is because you're already going all the way across on the top.
Right. And so if you, it depended on their, like if you wanted this one this way, or if, you know.
And I tried to
Do
talk
like
her into
that.
12-inch pay stones too.
Uh-huh.
She's like, no, I
That'd
want
be
the whole
easier.
basin bricks. And I was like, all right, well.
Okay, so did you have to do the bottom or just around the outside?
No, I did it all. I filled it.
Okay.
But I had to go to Lowe's to get them to do the numbers for
Uh-huh,
me.
right, okay. If you had just done this chapter first, then you would know. Okay. And I think I told you about this guy at UNA, and he was actually a math teacher. But he wanted to put rock on his driveway. And so he had to do the length and the width, and then he also had to do the height of it. So see, like that, you know. So it was like volume, the length times the width times the height. And he miscalculated, and so they dumped it all out, and it was this deep. And, you know, and even after he spread it out, it was that deep, because at first it was like this deep, you know.
I could have
I mean-
saved $5,000 if I did that right.
Exactly. He really wasted a lot of money. But anyway, so sometimes it costs you money to do that. But like if you're just doing this and this and this, and that's the perimeter. But if you've got to go, you know, across like that, okay, then you would have to do like 17 times 32, okay? And that would give you square units. And then you'd have to divide it by like the 4 by, is it 4 by 4 or something like that, which is 16, you know, square units. Okay, and you have to divide that into that and give you a rough estimate. But the problem is like, you know, in the corners and whether they're overlapping, and if you have some up or if they're all just solid, and, you know. But there are a lot of things in life that you do have to use math for, or you go to Lowe's and let them do it. Okay. All right. Now, 25 was another one. Okay, our plan on this one to get the shaded part is just find the area of that square, right? That looks simple, except, okay, we don't know the dimensions of that square. All right, so we just want the area of the one right there. Okay, all we know is this is 4 inches from here to here. And this is 4 inches from here to here. So what shape is that one?
That's a square.
It's a square also. Okay, I didn't draw my picture too well. Okay, now, I need to know how long each side of the square is right here so I can find it. All I know is that this is 4. If this is right in the middle, which it is right here, then that part right there would be 2. This part right here would be 2. Now, if I could use the Pythagorean theorem, which is a squared plus b squared equals c squared, I could find the length of that right there, which would be a length of the side of the square. All right, so 2 squared plus 2 squared equals c squared. So that's 4 plus 4 equals c squared, or 8 equals c squared. You have to take the square root of both sides to remove that squared there. So you get a C and whatever the square root of 8 is. Okay. Okay. So if you just do 8, on mine it's 8 second square root button. So it's about 2.8. So this side right here is about 2.8 if I didn't make any mistakes. Now, if I want to find the area of this square, if each side is 2.8, then I multiply that times that, and that would give me the area. Now, that is a very involved problem right there. And you had to know how to do the Pythagorean theorem before you could work it.
But first I applied that way, but it cannot work out because the answer is 8
Okay.
in
8.
square. So what I did is I divided into two triangles.
Okay.
We know the base is from top to the bottom. That will be 4. That will be the base, and then the center to the other side that will be 2. So we have high and base. So I calculate the first triangle, then get an area, then
You multiply by 4.
multiply just for 2, then can get the number 8. But
Okay.
for the first solution I cannot apply. I mean I can.
Okay. All right, let me show you. Now, on this one, what they did, they didn't go ahead and take the square root of that right here.
Yeah.
They said if this side is the square root of 8 and this side is the square root of 8, then multiply them together. Square root of 8 times the square root of 8 is 64, and the square root of 64 is 8. Okay. And what he was talking about was like dividing it up
Yeah.
into triangles and then finding the area of this triangle and then doubling it to
Yeah.
get that one over there. Okay. But either way, came out with the right answer. But let's see if let's see, times 2.8. Okay, you see it came out to close to 8. Okay, see if I did it that way and kept it in the calculator, it would come out exactly 8. But that's what they did. They just said that times that, would give you 8. Okay, look at number 26. What would your plan be on number 26? How would you find the area of the shaded part on that one? 26. Yeah, 26, not 28. 26. We didn't have that. But what would you do?
Calculate the area for both of the.
Both of the shapes.
Yeah.
The rectangle, and you would take away the trapezoid, right?
Yep.
Okay, and then that would give you what's left.
Yes.
See that? If you had this right here, and that, and just that right there, that's part of the problem, is figuring out what am I going to do on this problem. But if I did the area of this one and then took that away, see it's not there anymore, I'd have what was left. Okay. Look at 28. You didn't have it either. Okay, but if you had this and you had this in there, that. Okay. What shape is that one and that one right there? 28. What is that shape? It's got 4 right angles. Rectangle. Okay. So you take the area of the circle and do what?
The area of
The radius.
Minus the area of the rectangle, right? So this one is pi r squared, and then the area of that one is the length times the width. Okay, so you know what the length and the width is. What is the radius on 28?
the radius will find.
5. Okay, so you do pi times 5 squared, or 25 pi. Length times the width, 6 times 8, or 48. That would be your answer. You could do that on your calculator and get the answer. Okay, so a lot of it is just figuring out what in the world am I supposed to do. Okay, now, okay, another one I did was 27. Okay, Alright, your plan on 27 is to get the area of the trapezoid minus the area of the circle. Okay, so the area of the trapezoid, area is 1/2 the height times base 1 plus base 2. So the height of that trapezoid, see if this is 4, that's a radius, and you turn it up there, that's 4, that's 4. So the height of that whole thing is going to be an 8. And then the base 1, base 2, that's 29, half 8 is 4, so 4 times 29 is 116. So this one is 116. Area of the circle, pi r squared. Radius, is 4, so 4 squared is 16. So 116 minus 16 pi, whatever that is. Okay. I don't even know how they did the answer in the back. I hadn't looked. But anyway, I just wanted to show you how you would do it, in case you missed it. You know. Okay, 41 is another one. Okay. All right. Now this is similar to your problem. The cost of Pergo Select Helsinki Birch laminate flooring is $5.89 per square foot if Nancy installs it herself, or $8.89 per square foot if she has it installed by the flooring company. Determine the cost for just the living room, dining room, if she does it herself or if she does it with a flooring company. Okay, so first you have to know how many square feet are in the living dining room. So that's 25 times 22, or 550 square feet. Okay, then if she does it herself, then it's $5.89 times 550, or it comes out to 3,000 and something.
I think even 10 years ago, the prices were high.
Yeah, it's all high, and this is like, whoa, way long time ago. I've just been using the same book where people can pass them around, because it's the same stuff, just different numbers. Okay, 51 was another one that you had to use the Pythagorean theorem. Okay, to find the length of that cable right there. So it makes a right triangle. We know these two sides, so a squared plus b squared equals c squared. You always make sure that your c squared is the side that's across from the right angle. Okay, so it comes out to like 10,804, and the square root of that is like 103.4 feet long, or meters, or whatever this is. Okay, feet. Okay. Also, if anyone needs these notes, you know, if you need to look at them closer later, you can. 53 is also another Pythagorean theorem problem. You're docking this boat and you want to know how far to put it out there. Okay, so it's a 41-foot rope, 9 feet on the dock, and you need to know how far away to put the boat. So it makes a right triangle, a squared plus b squared equals c squared. Now this time, 41 goes in place of c squared. Doesn't matter on a and b. So I put 9 squared plus x squared equals 41 squared. And then I subtracted 81 from both sides. X squared equals 1600. So in order to remove the squared, you take the square root of both sides. So square root means what times what would give me x squared. So it's an x. So it's about 40 feet. Okay. Any other problems on 9-3? Now keep in mind that you put your marker on the area of a trapezoid. Also, right across from it is the Pythagorean theorem. So you've got an example of how to do the Pythagorean theorem that will help you with these problems. Okay, 9-4 is volume. Volume is length times width times height. Okay, it gives you volumes of rectangular solids, cubes, cylinders, cones, and spheres. Okay, and it has them all in one place on 508. Okay, then later it has polyhedrons, and then it has prisms, and then it has pyramids. Okay, so it's a million different formulas, but you just have to find the right formula and you'll be okay. Alright, and sometimes that's the problem. Alright, on number 13, wanted to look at this one. This was the first one that was like a prism or a polyhedron. So what you do on that one you first have to get the area of the base, which is a trapezoid. Okay, see that? Area of a trapezoid. So that is 1/2 the height times base 1 plus base 2. The height on that trapezoid is 10. Base 1 is 8, base 2 is 12. Work all that out, you get 100. Now, once you get the area of the base, then you just multiply it times the height, and that's the same thing as length times width times height. So that'll give you the area of the whole thing inside. So it's about 2,400 inches cubed. So, or feet, whatever this is, inches. Okay. Now, anything on that first page, 9-4, any other ones that you need to see worked? I'll be glad to work any of them. I have number 17 and number 19 worked. Okay, 17 is a pyramid. So you go back and you find your pyramid formula. It's on 513. It's 1/3 of the base times the height. Okay? And that makes sense because the whole thing would be this big, but if it goes up like this, that's about, it's 1/3 of it. So the big B is the area of the whole base of the thing. So this one is a square on 17. So area of a base is 11 squared. So 11 times 11 is 121. So 1/3 of 121 times the height of that thing, which is 13, so it comes out to 524.3 centimeters cubed. Number 19, you have to get the area of the base, which is a trapezoid. So you gotta get real familiar with this trapezoid formula. Okay, so 1/2 of the the height times base 1 plus base 2. So the height was 5, it's always a perpendicular segment, okay? And then the two bases are 7 and 9. Multiply all that out, you get 40. Then it's 1/3 of that base. The base is 40, so 1/3 of 40 times 8. And that comes out to around 106.67 inches cubed. Now, anything on this page right there? 515. Okay. All right, 21. Okay, 21 looks horrible. Okay. It is your plan. Remember to have a plan on these shaded ones. You get this big box, okay, which is length times width times height. We'll give you the area of that thing. And take away the cylinder. Okay? So, length times width times height is 72 meters cubed for that thing. Okay. This one, the formula for a cylinder is pi r squared times the height. Okay, so you have to go back over and find the cylinder, which is on 508. Pi r squared times height. This is just a matter of determining the shape, and getting the right formula and then working it out. So this one, the radius of that circle is a 1. The diameter is 2, but the radius is half of it, so it's just a 1. So pi times 1 squared times 4, in other words, 4 pi. So you have this minus that, 72 minus 4 pi. If you want it in numbers, it's 59.43, and that is meters cubed. Okay. Questions? If anybody needs me to do that slower, I will.
On the worksheet, can we do one on the worksheet?
Yeah.
See the perimeter and area, number 2, chapter 9.
All right, let's wait. Let me get this one done first,
Okay,
and then we'll
sorry.
get to that. Okay. I want to show you this last one here, number, 43, and then we'll get to the worksheets
Okay.
when we get through all this. Okay, the pyramid in Egypt, where the base is 720 on a side. It's a square, so it's 720 times 720. Okay, what is the volume? So the formula for a pyramid is 1/3 the area of the base times the height. So this times this, okay, gives you 518,400 times the height, which is 480, and then take a third of that. So it's 82,944, blah, blah. Okay, so that was another one. Okay, now to the worksheets. Okay, I think that's what we're going to do next. Okay. Now, all right. Okay, this is worksheet number 2. It's really faded up here, so you'll need to be looking at yours. Okay, now which ones you have? Okay, let me give you the answers first, okay? And then you'll know if you did them right or not. Okay, number 1 is a parallelogram. I know you can't see that at all. 2 is a trapezoid. 3 is a square, but it should have had, wait, that's the wrong one. Okay, sorry. Down here, number 2. Okay, 24 meters. Okay, the perimeter is 24 meters. Number 2, the perimeter is 24 meters. Number 3, it's 17 decimeters. Okay. Number 4, find the perimeter of a rectangle whose length is 12 and whose width is 7, so that's 38 meters. Find the perimeter of a square, blah, 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 it's 22. Number 6, the area and perimeter of a certain square of the same length. What is the length of a side of the square? Did you figure that one out?
No, okay, no.
Okay, all right. And this, you just had to use trial and error to figure this out. The area and the perimeter are the same. All right, so I tried a 1. Perimeter's 4, the area is 1. Okay, so that didn't work. I tried a 2. Perimeter 2, 4, 6, 8, area 4. That didn't work. I tried a 3. 3, 6, 9, 12 for the perimeter. Area 3 times 3 is 9. I tried a 4. And this is exactly the way I tried doing it. Okay, area 4 times 4 is 16. Perimeter 16. Okay. Okay, and it was just guessing. Okay. So, what is the length of one of the sides? 4. Okay. Now, it's not the exact same number because this is like, say, inches squared, and this is just inches. But it is the same number, 4.
Yeah.
Now there. Okay, so that one was just trial and error. Okay, number 7. I got 3 inches. The width is 3 inches. I'll show you how to do these in a minute. Number 8 is 112 inches squared. Number 9 is 91 square units. Number 10, 90 square units. And number 11 is 153.9 inches squared, or 49 pi. 153.9 inches squared. Okay. Now, which ones do you need to see worked out?
11 kind of
11.
messed with me a little bit.
Okay. All right, on number 11, this was a circle. Okay. And this is 7 inches. And 11, find the circumference and the area. So you got to know your formulas. Circumference is pi times d, and that's the same thing as 2 pi r. Okay. Area is pi r squared. Okay. So here is your radius. Now, pi times d, what would be the diameter?
8.
Mm,
No, wait, is that 4 or what is it?
that's a 7 right
14.
there. Okay. So your circumference is 14 pi. You multiply that on your calculator and get the answer. This one is pi times the radius, which is 7 squared, or 49 pi. Okay. Got to get the right formula and also know what circumference, diameter and radius is.
I feel
What'd you
silly
do?
about it. I feel silly about knowing my problem.
Okay. What'd you do?
I thought where the inch sign is, I thought that was to the power of 11.
Oh,
Like,
okay.
I was like, well, how the heck do we do that?
Okay, all right. I understand. Okay. All right, other ones on that page.
I spent like 20 minutes trying to figure it out.
Oh, okay, yeah. That reminds me, there was some problem where it was like 4 to the 3rd raised to the 2nd on the last test, something like that. And a lot of people thought that was 43 squared.
Oh, yes,
Uh,
Yeah,
yes,
right.
yes.
And so I had several people do that, and I finally realized what was going on. Okay. All right. Okay. The worksheet was easier than what was in the book, if you could read my writing. Okay. Now, have we gone over? Oops,
The probability.
have we done this? I want to do this first because it's easier. Okay, have we done this yet? Okay. Alright, let me tell you the answer and then I'll work the ones that you missed. Okay, number 1 is 83.3 with a bar percent, or 83 and a third. 2 is 0.24, 24 hundredths. 3 is 70. 4 is 25%. And 5 is 70%.
I missed number 2.
Okay. Alright. Well, I want to show you what the equations look like on all of these. Alright. 10 equals what percent x of times 12. These you just change them into what they stand for. So this is 10 equals 12x. Divide through by 12, and that's how you get your answer on that one. Okay. Next one. What number x is equals 3% of times 8? What number is x? Is always means equals. 3% of always means times 8. Now, before you can work this problem, you have to do that. Change that into a decimal to get it to work out. Got it? Okay, next one. 7 is 10% of what number? Okay, so 7 equals this. You want the x by itself, so you divide by 0.10. Okay, and that's how you get that answer. Got it?
Is it 70?
What is it? What is that number? What number are we on? Okay, number 3, 70. Number 4. What percent of times 108 is 27? Okay. Divide, that's 108x equals 27. So divide by 108. So it came out to 25%, or 0.25, and you made it a percent. Okay, last one. What percent of 60 is 42? What percent of 60 is 42? So that's 60x equals 42, divide by 60, and then make it a percent. So it came out to 0.70 or 70%. Any other questions? Okay, that's the easy one, wasn't it? Covered a whole chapter there. All right, now to get to the probability page. Okay, then we're going to take a break. I'm tired of talking. Okay, now.
Wish you could pass that along to some of our other instructors.
Okay, now, some of these were easy, some were hard. But once I show you how to do it, the hard ones will be easy. Okay, now, you've got 20 pieces of candy. Okay, the probability is a success over the total. What you want to happen versus what could happen. Now, there are 20 pieces of candy. I left out 6 green ones, so that may have caused you some problems. All right, what's the probability that you will select a red piece of candy? There are 3 red pieces of candy out of the total number 20. So there's A. Okay, B part, a green piece of candy. There are 6 out of 20, which reduces to 3/10. Always reduce your percent on the probability. Red or yellow? Okay, now, red we had 3. Yellow we had 4. If it says or, put this on this worksheet. Or means to add them.
Yeah.
Okay? So that's 7 out of the whole thing, 20. So that the C part is 7/20. Okay. The next one, the D part, neither a red nor a yellow. Okay. So you've got 20 minus 7. On this worksheet somewhere, write nor means subtract. So you've got 7 20ths. You take the 7 from the 20, which gives you 13 20ths. That's what's left. So 13 20ths is the answer on D. The E part, anything but an orange piece of candy. Okay, there are 7 oranges, so how many are left over? 13. Okay, out of 20. A purple piece of candy.
Trick.
Right. 0 out of 20 or 0 or none or whatever. Okay. Now I'm going to give you the answers and I'll work the ones that you need to see worked. Okay. Number 2 is 1/10. B is 3/20. C is 1/5. That was 4/20, which reduced to 1/5. D is 7/20. E is 7/10. F is 0. Now 2 is exactly like 1. So on the C part, you had to add them, and on the D part, you had to subtract them. Okay. 3, A 1/6, B 1/2, C 1/2, D 1/2, E 1/3, F 1. Now I'll come back and work these in a minute. 4, A is 1/3, B is 1/6, C is 1/2, D is 0, E is 1. Okay. Let's see. 5, 1 out of 52. B is 1 out of 52. C is 1 out of 13. D is 1 out of 2. E is 1 out of 4. F is 1 out of 26. That was 2 out of 52, which reduced to 1 out of 26. 6, A is 1/4. B is 1/4. C is 1/2. D is really weird. It came out to 4/13.
We didn't get a D.
Okay, all right, didn't do what?
It didn't come out.
Oh, okay. All right, y'all were lucky. Okay.
There's 2 that I missed. It might be me
Okay.
because I don't know anything about cards.
Okay.
But on
Could
number
be.
5,
Uh-huh.
I missed B and C. I reduced it down to 1 over
Okay.
26 on both of those.
All right. On
So I must have missed.
the B, 2 of hearts.
There's only 1, 2.
There's only 1 2 of hearts.
Oh, okay.
Because you've got 1 2 3 4 5 whatever
I
like
know
that.
absolutely nothing about
Okay. And then the C part was. Is that the one? Another
Yes,
one.
I
C.
had the same answer.
Okay. There on C there are 4 2s.
There's 13.
Yeah, I put it on C.
Uh huh.
On C, I put 4 over 52 at first.
Right.
And
Uh
then I reduced it down to 2 over 26, and then 1 over
1 over 13.
Think of it
Okay.
like this: is there's 2 through ace in every suit, and once you get to a 10, it goes from Jack, Queen, King, Ace. And there's 4 suits, so all in all, there's 52 cards.
Right. Mm-hmm.
I had to look it up a bunch of
Right. I understand. Yeah, because if you don't play, you don't know, and you might not remember. Okay. All right. Everybody okay on that one?
Yeah, that was a lot.
Any of them?
That was a lot better than 9.4.
Okay, go take a break. About 5 minutes or so. Good job for me. I had to work all those last night. To make sure I had them.
That's a long. It take a long
Yeah,
time.
see,
to
we're
even
gonna
do
teach you how to play
it.
spades this weekend, man.
Right. Yeah.
Yeah, I try to finish all until 2 a.m.
Oh, man. Yeah, I was working all of mine to make sure, because sometimes if I haven't done them in a year,
You gotta
I won't remember, and
think
it'll
back.
take too long for me to figure it out while I'm in front of y'all.
Yeah, yeah.
So I just went ahead and worked them, but I had all that, and then my grandson had trouble with his math, and so I helped him for a long time.
That's kind of ironic. He's going through the same thing at the same time.
It is.
Was he in 10th grade or
He's in the ninth.
9th grade?
Taking algebra, but he's already into. Oh me, he had problems like, which you will have to do next time. He would have things like 3x to the 4th y squared plus 6x squared y plus let's see.
Sorry.
9x, something like that, and it would say factor it. So you would have to like bring out 3 and x, and then divide 3x into that. So then you would have to like factor that.
There's a
part.
lot of,
But
lot of,
anyway, yeah.
poor, lot of poor trees having to go through a lot of persecution.
That's right. That banana smells good.
Yeah.
You must be a pretty smart kid going through all that, 14, 15 years old.
He is. He's very smart.
at first it was awful. Cause there's like little halos around
Yeah,
all the
especially
lights.
with these LED lights that people are having now.
Yeah.
I mean, I get blinded by them.
Yeah.
Like Barron flashed me when I was leaving last night to get some food. About 9 o'clock. Came in and got like from here to where the projector screen is and it was like wink wink and I was like ah! And now those have those LED lights with the trim around
Yeah.
them too, you know? Oh man, they're even brighter.
If I see somebody with their bright lights on, like I always flash them, just tell them to turn them off because like that's dangerous.
It is.
But
Especially for cars that are lower to the ground than you are.
yeah.
I mean, it really is. Want a fireball?
I'm good. I can't handle hot stuff.
Believe it or not, it actually helps with my warming testing.
Oh yeah.
I guess it's the cinnamon in it.
The my grandfather would take those and like the red what's it called the gum that's like a
Big Red?
Yeah, Big Red. Yeah.
I just wish I could get that thing to get bigger. I know y'all can't see it.
Yeah, I don't know. That's weird that it stopped working.
I know, it just, a little glitch in it, I guess, you know. I wonder if, no, I don't know, who knows? Okay, what I can do is grab a magic marker. It makes it where I can't use the back of my paper, but it will work. Alright, this is the last thing we're gonna do. Okay. There is something I want to show you though before I do that, pertaining to what we were talking about a while ago, which you probably will have to do this next year. Something like this. Do you remember something called factoring
It's so long.
in algebra? Right. Okay, you make things like this. And then you would have to break it down into x, and plus, and 9, this. And you use something called the FOIL method, F-O-I-L, first, outside, inside, last. And x times x is x squared. Outside, 9 times x is 9x. Okay. Inside, 9x, so that adds up to 18x. And then the last one's 9 times 9 is 81. Remember doing that, David? Okay. Do you remember doing it? Okay. We have things like x squared minus, let's see.
I'm sorry.
That's all right.
We'll forgive you this time.
You have something like this. This is nothing you gotta know. I just wanted to see if you remember this. You'll probably have to do it in the next one. Cause, factoring is a big deal in math. Boy, you can't see that. Okay, be an x and an x and a minus and a minus. What do you think might go there?
Is it 26?
No, this is 36.
36.
This one was 81 and I put a 9. So if this is 36, what do you think that's gonna be?
9 and a 4?
Close. 6 and a 6.
Yes.
Okay.
You want to
So
break it down to the
6x,
simplest, right?
6x is 12x. Right. You're factoring. Okay. Also, they did things like this. Multiplying a trinomial times a binomial. X times this is 3x to the third plus 2x squared minus 5x. This, and then do this times this, 6x squared plus 4x minus 10. And then you combine your like terms. Do you remember doing anything like that?
I never did anything like that.
Okay. Uh-huh. Okay.
If I did, I'll try to forget it.
Right.
Lauren broke that down.
Anyway, those are just things, there are a lot of different things. I mean, I don't know how detailed he get, I just know that I've heard he's a good teacher, and so that's good. But, I just hope that, you know, it's not too bad, but you just can't do everything that you're gonna need to know without doing the course, you know. Okay, the next thing is chapter 13 on statistics. Okay, now,
Would you like to use this pen?
mhm,
I cannot
okay,
see
I've got a big one I'm gonna write with.
that. Okay.
Okay. Mm,
Oh, much better.
Oh, yes. That's good.
it's terrible that that quit working. Okay, statistics is just some number that you derive from a set of data to represent it, you know, or describe the data. People can use statistics in all kinds of ways to fool you, to make you believe a particular thing. You know, like they might say the average number of participants in the blah, 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 you know, is this. Or they might say the median number of blah, 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 blah. And so you have to be real careful on which measure of central tendency that they're using. And I'll give you some examples of that in a minute. Okay, so we're going to talk about some measures of central tendency. Okay, and this has to do with a bunch of scores, and the first one is the mean, which is the same thing as the average. You have been averaging things most of your life. Okay. The next one is the median. What is a median in the road?
In the middle.
Middle, okay. So this is the middle score. Okay. Next is the mode, which is the one that occurs, the score that occurs the most often. And the MO will remind you of that, most often. Okay. Number 4 is the range. If I say on the last test the scores ranged from 70 to 97. Okay. So this one, you take the largest minus the smallest number to get the range. Number 5, you have the mid-range. Okay, you add the largest plus the smallest and divide by 2. Okay, and then there'll be one more thing that we talk about, and we'll get into that in a minute, and that's the standard deviation. Okay, now let's look at some examples of some data. We're going to have 90, 85, 92, 65, and 71. Now we're going to try to find the mean, the median, the mode, the range, the mid-range of all these different scores. Now the first thing you do is put them in order from largest to smallest. So do 92, 90, 85, 71, and 65. Okay, do largest to smallest. Okay, all right. Now, first get the mean or the average, and all you do is add them up and divide by the number of scores. So see what you get. You get 80.6. To check me. Sometimes this calculator doesn't work very good. Okay, is that what you got?
80.6.
Okay, good. All right, the median is the middle score. Which one's in the middle? 85. Okay. All right, the mode.
92.
This one doesn't have a mode. Okay. No mode.
Oh.
In order for it to be a mode,
That'd be more
you'd
than
have to have
once.
more than one of them that were like 90 or, you know, whatever. Okay, let me get sheet paper in a minute. Okay. Now, the range, largest minus smallest. That 27. Okay. And then the mid-range, have the small one and the large one together, divide by 2. Oops. $78.5. Is that what you got? Is it? Because my calculator gave me 100 and something the first time. I need that
I
one
got
right.
24.
Yeah, that's what I got. 124.5.
Try it again. Cause see,
78.5. Do it all together and it'll give you that crazy answer. Do it separately and it'll give you the right answer.
right. Because it's got to be in the middle of 92 and 65. So add those together. So it's got to be in the 70, 80
Yeah, I got
range.
78.5.
Okay. All right. Because my first time I got 120 something. I'm like, nah, no way that's going to work. Okay. All right. Now, so you got the mean, the median, the mode, the range, and the mid-range. Okay. Now, this is the bad part about using this. You have dots all over the paper. Okay. You use these numbers and find all of those. 51, 60, 72, 81, 83, and 93. Okay, find the mean, the median, the mode, the range, the mid-range. And remember what you do first.
I already get a bump. Can there be more than one median?
Yeah.
Mm-hmm. Well, no, not median. There can be more. Yeah, on this one, you have an even number. So I didn't tell you what to do on that. If it's an even number of them, you add the two together, then they're right in the middle, and divide by 2.
I vaguely remember that from school.
Mhm.
I wasn't sure.
That's actually the one thing I've never forgotten. I can't believe that. I can't even remember to tie my shoes most morning, and yet I remember that.
So if you have an odd number of them, you're going to have a median right in the middle. And then otherwise, you've got to do it the other way.
So if you have 6, there will be just you put 0 if it asks for it, right?
Mm-mm. No, you'd add these two together and divide by 2.
Okay. So you would do like you would the mid range.
Mm-hmm.
Okay.
Yeah. Mm-hmm. Okay. Okay, did you get like 73.3 with the bar for the mean?
Yeah.
Okay. Median, 76.5. Mode, 9. The range, 42. And the mid-range, 72. Okay. Now, I thought I had printed out enough of these, but I don't think I did.
We do, when we're trying to figure out how we're doing with like attendance and the contribution and stuff at church. We have to do a lot of this kind of stuff.
That's right. Okay, I'm gonna give you this problem, so you'll need to write it out. The employees and salaries are listed for a particular company, and you're gonna find some different things out about this company. Okay, let's see. You've got Mr. whatever his name is, 35,000. Mr. Hart, 30,000. Mr. Hobb, you just write these down. And we have Miss Chung, 27,000. Miss Wolski, 26,000.
It's either that or
Always.
Jewish. I don't know.
Miss Dugan.
My mom's maiden name was Ostashevsky, I still can't spell it.
Wow. Okay, and these are the employees. And then salaries for these people. Notice we have the men here and the women over here. First thing, what are the women going to do?
Rise up.
Yes, exactly. We're not being paid equally. All right, now,
I was gonna say that.
what is the mean of all employees? What'd you get?
30,000.
Okay. So the mean or the average salary for all of these employees is 30,000. What is the mean for the women? And then the mean for the men.
For the golly,
Women would be 25 grand and men 35 grand, wouldn't it?
they're making $10,000 more than the women. My goodness.
Until this is.
Lawsuit.
It's funny, I was actually, the thing about it is, when you just look at it like this, the women may be secretaries, the men may be engineers.
Yeah.
You know, you don't know. But I actually, this happened at a place, I knew some coaches that the coaches of women's sports were paid like so many $1,000s less than the coaches for men's sports. This was like in a high school. I mean, you know, and even though it was a man coaching a woman's sport, he got paid a whole lot less than somebody who, and I was surprised at that, but it got changed. They had a woman that was over the business office. And so it got changed. But anyway, a lot of times it has to do with their educational background. You can't just look at a set of data and say these women ought to protest and blah, 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 blah. And that's why it's good to know something about statistics, because whoever, like, if you were arguing for the women, if you were a lawyer, you know, you could just use that and say the average for the women is only 25,000, but the average for the men is 35,000. You know, we need, you know, justice here.
It goes back
Kind
to
of stuff.
what we talked about at the beginning, inductive reasoning.
Mhm.
We only have so much of the information, so we might go some kind of probability, but you can't
Uh-huh.
know for sure without having all the information.
Right, exactly. Okay, if you were, let me see. All right, find the median for, let's see, for the women and for the men, the median salary. For the women and for the men.
26.
Okay. Okay, now find, let's see, the median for all of them.
Oh. 28,500.
Mm-hmm. 28,500. Now, if you were a lawyer and you were arguing for the company, okay, do you see how you could say, well, the median salary for all employees is 28,500, you know? We don't need to do anything. That's a good salary. Okay. But it just be real careful when you hear something, because it depends on, in this day and time, whether it's a Republican talking, a Democrat, or Libertarian, you know, or whatever. So you have to be aware of what they're trying to do. They're trying to sway you one way or the other.
You can see on, like, you can go on the internet, like on YouTube or something, and see on both Fox and CNN where they would use like charts and statistics.
Yes.
And I think obviously, if you really just take time to look at it, like it skewed some things on charts or whatever, and you gotta take your information with a grain of salt.
Exactly.
Yeah.
Right. Yeah, I don't ever believe, you know, and it's just like polls and things, you know, because sometimes they've only polled Democrats about the Republicans, and other times they've only polled Republicans about the Democrats. So
Well, look,
you can't believe all that.
with the like Hillary was like definitely gonna win last year, then
Yes.
Trump ended up winning, but they didn't poll everybody. So,
Exactly.
You know,
And all the polls were skewed,
yeah.
you know. And a lot of times they don't ask people that are going to vote, you know, the registered voters. Or even if they're registered, they might not even going to be voting. So you can't, you know, tell about all that.
Another problem is half of these people they go up to and be like, who are you going to vote for? Who's running? Who are they?
Yeah, exactly. They don't quite know what's going on. Okay, now, the next thing we're going to do, and this is where you need some brain power here. I put all my notes up. Okay, let me see what I did with them. Okay, is standard deviation. This is just another measure of central tendency. And, okay. And this is kind of, okay, it's a measure of dispersion. How do you spell dispersion?
DISBURTION.
That, okay.
Oh, yeah.
Whatever, I don't know if it's
That'll
an S
work,
or T.
that's right.
Okay, that that considers all of the scores in a given set of data. Okay,
Dispersion.
let's see, yes, dispersion.
Big word.
Okay. Right. In other words, how are they all thrown in there? What do you know about 'em? Okay, now, here are the numbers. This is our first example. We've got a 60, a 65, a 70, a 70, and a 70. I'm assuming these are grades, you know, but who knows? Okay. Now, kind of low on this test. All right. The first thing you do, put them in order. Okay. If you don't do that, you end up missing the median or something like that, or the mid-range. Okay. First, find the mean. Okay. Okay, 67, right? Okay. Now, the second thing that you do is you find out each score's difference from the median. Okay, so this is called the deviation from the mean. How much do these scores deviate, okay, from the mean? So if you got a 70, how many? 3, 3, 3, 2, and 7. Okay. Now, the next thing you do is you square the deviation. Okay. So, 3 squared is 9, 9, 9, 4, 49. So you square, or do that squared. 3 squared, I'm going to put this here so you can see it. Fourth thing you do is find the mean of these numbers here. Okay. And I believe it's called the variance. Okay. Then find the mean of the squared deviation. That is called the variation. I mean the variance.
The last number's a 16, right? The 9994. What is it?
49.
How'd you get that?
7 squared. 3 squared, 3 squared, 3 squared, 2 squared, 7 squared. It's the difference or the deviation from the mean. Okay, now then you find the mean of these numbers. You add these up, divide by 5. Okay, what'd you get?
I got 16.
Okay, that's right. So the variance is 16. Then the last thing you do is take the square root of it. Square root of the variance. So the square root of 16 is a 4. So the standard deviation is 4. Now, what the standard deviation means is that if you have a small standard deviation, that means your scores are like closely grouped together. So if you have a large standard deviation, that means these scores are widely scattered. You think, what does this have to do with anything? I don't know. No, you can tell if you see the standard deviation, most of your grades were right here, you know. And there's a lot of different teachers that use this in all sorts of different ways. I don't ever use it, but some people do. Okay, here is example number 2. Okay, and you have to kind of, it's a plan that you're going by. Okay, your numbers are 20, 26, 22, 26, 28, and 34. Okay, does this one have a mode?
Yes.
26, okay. Yeah, it has a mode. It's the one that occurs the most often. Okay, now, all right, so the first thing you do, find the mean. We'll put them in order first. Okay. What'd you get? I got 26.
Yeah, 25 and a half.
Yeah. Should come out even. I don't either. Did you get 26,
I
everybody?
think this was made by Koreans.
Okay. Now the second thing, you have to figure out the difference in the mean and each number. So is that what? 8? This one is 2. This one is 0. This one is 0. This one is 4. And this one is 6. Right? Difference. You're trying to figure out if you've got that the mean is 26, so that's 8 difference from that one, 2 difference from that one, 9, 9, 2, and 6. Okay. Now, some people keep up with, like, if it's smaller than that, they have negatives and all that. It doesn't matter. You're going to square them, so they're all going to come out positive. Next thing you do is take each one of these numbers and what? Square them. Okay. So that's the 64, 4, 0, 0, 16, and 36. Is that right? Then find the mean of that. Okay. My calculator's stuck. Okay, 20, is that what you got? That's what I had on my paper over here, but my calculator's completely stuck. Okay, so you first find the difference, you square the difference. You add them up and divide by however many you've got, or in other words, find the mean of that. And then you take the square root of 20. Okay. Okay, so it's about 4.5. Okay, you can like round it to the nearest tenth or something like that. Okay, so these numbers are pretty close to each other because it's still a pretty small standard deviation. Okay. Now, all right, we have some problems to do. The first one, you just doing the mean, median, mode, range, mid-range, these numbers right here. Then you're finding the standard deviation of those, and the mean, the median, the mode, range, mid-range, and standard deviation of one problem. And good luck. But it's a matter of just memorizing the steps that you go through. And I have to, when I haven't done it in a long time, I have to do the same thing you're doing, which is look at the pattern. And I have them all worked out, so if you need to know the answers, I've got them right here. I think. And remember to put them in order. Get lost, just let me know. I'll try to help you. If I can.
doing the standard deviation
Mm-hmm.
and you get your average and you start going through minusing and plussing however far your way. If you get a 0, the same number as your average, would you still include that number as one of the that you divide into?
Good question.
I don't know if it's right or not, but
You hope you're finished, right?
then it starts right here and then it's up there. Okay, gotcha. I think there's a number missed here on number 2. I think because there's 9 numbers here. I think 59 was missed out right here.
It's obvious that it's not there. So what answer did you put on that?
Let's see. I got a.
53.
Yeah.
Oh, maybe.
49. Sorry.
Okay.
And then on mode, and then 64 on range, 53 on mid range.
Okay. Sometimes nobody ever tells me, you know.
They're afraid.
Use
You're gonna
it
feel
for
this.
years, you know. I go,
Oh
I wonder
yeah,
if I
those
missed one.
surveys that y'all put to unlock our grades. And I heard a couple students say, "I just trashed my teacher." I was like, "Well, I won't see you next semester."
Yeah, you don't do that before the final test, do you? you what I'll do before we leave. I'll give you the answers to these so that you can know if you have the right answer. Providing I have the right answer. But before I do that, this is a bonus for the test. These were the test scores from the last test. So find the mean, median, mode, range, mid-range, standard deviation of those test scores.
Those are my test scores, right?
Those are our test scores.
She's like, keep dreaming, fatty.
We got the same on the rest of them. So
Okay.
those are-
Let's see how they look on this. Okay, where'd you get it? Okay,
Let's see.
just number one?
No. Like,
Oh.
number one, like, this.
Oh, okay, I see.
E.
What you got. 88. Okay, 2. Okay. Okay, did you get 64 point something or 65 on the range on number 2?
Number 2, I got 64.
Okay.
Mm-hmm.
Okay, so that was just track from or something. Okay, 3. If you copied that down, yeah. You can copy it down while I'm doing this. Oops. Okay, this one is right. But I have standard deviation is about 2.5. And then this one. I'm gonna go ahead and give you the answer so that you'll know if you're doing it right or not. These are about. Well.
Doing the bonus
Okay.
one. Oh, you're fine.
You get 1.6 on that one? Is that what you got?
Yeah,
Or
1.6.
did you get 2.6?
Let's see. I think 2.6 was what I got before I did the root or something like that. I don't remember.
Okay.
It's too far back.
But I don't have an F on here. I don't have mean, median, mode, range, mid-range. And then F is supposed to be standard deviation, so I'm not positive if that's right or not.
Well, yeah, I ended up getting
Okay.
1.6.
Okay. That's what I had, so I hope that's right. Okay. 6.
This one's a little. The bonus is a little tricky because it has a decimal in it.
Uh-huh.
So I have to really think about that.
All right.
I'm just commenting on words. How do you do a number that way?
You do the differences and then square, like the mean was 11, so that's 3, so you square it, 3 and 3 is 9.
At least like that way.
Then you add it and find the average of that. Then, it's just.
And then you square that.
There's some step in there that you need to try to get right. And this one, when you get to the end, is about 1.6. There's something that you're a little bit off.
I'm not squaring them with deviation. So I'm squaring it at the end, but not the deviation. Okay, I got you.
Oh, yeah, I checked the rest of it, didn't I?
That one, that's the board problem.
Okay, I'm
And see, I didn't.
kidding now.
Oh, bonus.
Yes, bonus for the test.
Oops. Do we show you when we get that bonus?
Just
done?
wait till next week.
Okay. I hope I get it right, 'cause I need it.
You ain't got to come get any points on the workshops or seminars.
Yeah, I'm usually busy during those days.
Uh-huh. Yeah. So my license that killed me.
We, I say pretty active during the week at church.
Mhm. Okay, let's see, the next week, we'll just come, I'll go over any questions that you have. If you need me before then, take a picture of it, send me, I'll correct and back or whatever. Now, the best way to study is to look at your old test, go over all those, look at your notes, through, make sure, like I said, you put markers in your book on different pages that you need, because there's several of them. It's like when we did where you had to do something like, I don't know, let's see, 32 or something like that, square root of 32, and you couldn't use your calculator, and you had to break it down into like 16 times 2. Most of the time you see 4 times 8 first, and that'd be 2 on to 8. Then you have to break 8 down into 4 times 2, like this. If you see it first, it just takes you one step. But a lot of times you don't see it, So there's a lot of things you haven't done since the last test, or maybe even, the one before, because I can't put everything on every test, that we've had, or it'd be 200 problems, But just make sure that you go through and look at each thing and mark things that you have trouble with. And it's just like if you've got 2x to the third times 4x squared. Multiply your whole numbers and then add your exponents. Your rule when you multiply is to add them. When you divide, what's your rule? Subtract them. Okay, if you've got a power to a power, you do 2 to the third, x or 3 times 2 is 6. So see, those are things that you don't use every day, and if you don't go back and look at it, you'll go, I don't remember how to do that. Also, bases, like if you've got to do, let me see, 7 and base 2, change it to base 10, okay? No, that doesn't work out. It's like, let me see. And base 2. Let's make that base 10. Remember, this is always your 1s. This is your 2s. 2 times 2 is 4. 2 times 4 is 8. Okay. And then you've got 1 8 plus 4 is 12. 14, 15. So that'd be a 15 and base 10. If you've got, let's see, if it's base 5, your columns are 1, 5, 25. Always think about what you do in base 10. It's 1, 10, 100, 1,000. So you're multiplying each one by 10 because it's base 10. If it's 5, you're multiplying by 5. If it's 2s, you're multiplying by 2. Okay, things like that. If you haven't done them, you know, if you don't study, you're going to miss a whole bunch of them. Okay, so please just study. And we are through.
So next week we also submit to you the notebook.
Okay, yes, I'm glad you mentioned that. I just want, we'll all grade them while you're in class. Let's see, well, no, you'll have to leave them with me. You know, maybe during a break or something, you know, I can get them graded. But, because you're going to be using your notebook with your test. But just make sure you have everything that we have and put it in some kind of order, okay? If it's just all smashed in there, you're not going to get an A. Okay?
So I can't just bring you the folder in the spiral notebook.
Okay. You can if they're in order. I mean, I'm just saying don't.
Would it be best to like tear up the pages from here and put them in this folder? That way it's all in one thing for you.
It doesn't matter. I can see both things. Some people do notes, homework, notes, homework. Other people do all their notes and all their homework. I don't care how you do it as long as I can find it.
I'm going to organize
As
mine.
long as it's neat.
Yeah.
Mine's a
you know.
variation of
Yeah,
everything.
mine's
Right.
dumpster fire.
And if it's neat, I mean, like David, see, I can tell by looking at his, he'll probably have 100 on his, you know. Or if he missed some of his homework, 95, you know. But anyway, so just make sure you have it all in some kind of order, and you'll do good. Everybody's doing good. Y'all have been the best class I have had in a while because every single person has been doing their homework most of the time. What happens, most people have quit about midway through, and then they make terrible on the final, you know. But,
Well,
you
and
know.
Matt Gargis, he said that he said pretty much he sets up his class the same way that if you even halfway study for the test, but you do your homework, then you're fine.
Right, you're gonna make it. Okay, and I've heard he's good, so that's good. The biggest problem with that is making yourself do the work and do it every single week.
Yeah.
Don't wait, or you'll get hopelessly behind. Because even though you've had a lot of this, there'll be a lot of stuff we haven't had because I can't cover it all, or it'd be that class.
Yeah.
Okay.
Thank you.
Next week.